Well, hey, look at this. We're talking about arithmetic sequences. How exciting. You're going to want to pencil some good paper. We're going to talk kind of mathy today, and I'll unpack it for you. You might have to watch something a couple times, but let's get ready to do this. Get a good glass of water, have a good snack, and let's go ahead. Our objectives are to identify and extend patterns and sequences, and to represent arithmetic sequences using function notation. And there's actually a lot more to today's lesson than that, but that's a good starting point. So just like wooden posts and rails, there's a bit of a pattern that builds through each one. We have a name for that pattern that builds out. The number of pieces of wood used in the section, and so on, they do form a pattern or a sequence. Okay, so sequence really, that's one word we're going to use today. A sequence is just talking about a pattern. It's an ordered list of numbers that form a pattern. So when I say sequence, we're just looking, it has a very specific pattern to it, and it's not random numbers. Each number in this list is called a term. Okay, so I'm also going to be using the word term. So term is the different results in this pattern. As we put something in, like in a function machine, when I put an x, as I get y out, the pieces of y are a part of the term. So let's just dive into this and see what happens. All right, when you identify a pattern in a sequence, okay, look, because a pattern makes a sequence, you can use it to extend that sequence. So to kind of keep going, find the pattern, use the pattern. You can also model some sequences with a function rule. And that's really what we're growing into, is trying to create that rule, find out what the function is. You guys have been doing this probably for a while now, maybe what that function machine thing is, put something in, get something out, what is happening in the machine. So for instance, here we go from 5 to 8, 8 to 11, 11 to 14. These things are all going plus 3 each time. Every time, and so we have found our arithmetic sequence. We can use our arithmetic sequence to find our next two. So 14, we got 3 more, which is going to get me to 17, and we got 3 more, which is going to get me to 20. Same with this one over here. I've got 2.5, 5, and 10 and such. So I can see from 2.5 to 5 is going to be, this one's doubling. And this one here is also doubling, and this is here doubling. And because I see that it's a consistent pattern here, I know that I can say that this is an arithmetic sequence. And because I identify it as arithmetic sequence, I can continue to use the pattern. Times 2 is 40, and I can go times 2 more, which is 80. I would like you now to look at each one of these, A, B, C, and D, and I want you to describe the pattern of each sequence and what are the next two terms. So first, identify it as an arithmetic sequence, and then use the pattern you found. Press pause and work it out. All right. As we look through each one, on A, I needed to add 6 to the previous term to get the next one. For B, I needed to subtract, let's see, no, I was multiplying. I need to multiply everything by -2 to the previous term to get the next one. And then C, oh, that's not true. I just need to multiply everything by half. That's what I'm doing. Yeah, that's not true. Everything is being multiplied by half from the previous term to get the next term. For C, that's what's going on here. Everything's being multiplied here, multiplied by -2. That's what's going on. That's why the values are switching. And then for D, you're going to add 4 to the previous term to get the term you're looking at. Okay, now these ones actually go kind of quickly. You're just looking to determine, is it indeed an arithmetic sequence? And you can identify that by if there is a pattern between them. And if I look at these, I see it as +5, +5, +5. That indeed is an arithmetic sequence. 6 to 9 is +3. The next term is 9 to 13, which is +4. 13 to 17 is +4. It's close, but this is indeed not an arithmetic sequence, not a pattern to it. So again, that debunks that one. All right, I would like you to give it a try on these ones. Press pause and determine which of these is arithmetic sequences. A is not an arithmetic sequence. B is. It's going up by 2's each time. C is It is 1. It's minus 6 each time as it goes along, and D is not an arithmetic sequence. So just looking for a pattern to identify it. Okay, this is a little wordy. We're going to get a little mathy on here, so be patient with yourself. Okay, a sequence is a function. Okay, a sequence is, okay, so here we go. A sequence, which is a pattern, is a function. Okay, functions are each input has exactly one output, so each x has its own answer. Okay, a sequence is a function whose domain, that's my x value, is natural numbers, and whose outputs, okay, that's the range, the number they're putting out, is the terms of the sequence. Okay, so that's important. So we're looking at the different terms. If you didn't totally understand that sentence, that's okay. We'll just keep playing it out, and hopefully that'll come to you. You can write a sequence using a recursive formula. So here's a new one, and there's two formulas we're going to talk about today. First one is recursive. This is a function rule that relates each term of the sequence after the first to the ones before it. Okay, so this is saying in order to get my value, I need to know the previous number because each number is dependent on the one before it. To get to the 19, I needed to know the 15. To get to the 15, I needed to know the 11. To get to 11, I needed to know 7. So really, all of my answers, all of my values, all of my terms were dependent on the number before it. And that shows up in my recursive formula. So for instance, right here, the value of term 1. Okay, and we're going to let a to the n be the value of the nth term. So this is like what we're looking for. So this is what we're looking for, and we're going to ultimately try to grow into that. Okay. All right. So value of term 1. This is what I know. This is my first term. So my first term is going to be 7. That's my first value. Okay. So my value of term 2 is going to be this. It's going to be whatever my value of term 1 is plus 4, because the common difference is 4 between each one. 7 to 11 is plus 4, 11 to 15 is plus 4, 15 to 19 is plus 4. So that's the common difference between them. That's the pattern that I'm ultimately going to be using here. Okay. Now to find my third term, I needed the second term plus 4 more. To find my fourth term, okay, to find my fourth term, I need the third term plus 4 more, and that gets me my 19. So if we kind of put all that together, to find the nth term, okay, to find the nth term, I take the nth term minus 1, because I'm always looking for the previous one. Now if you look at that, the nth term, so my nth term, and you can see that played out right here. So my fourth term is 4 minus 1, which is 3. My third term is 3 minus 1, which is 2. My second term is 2 minus 1, which is 1. That's happening right here. My nth term is my nth term minus 1. My fourth term is 4 minus 1. Third term is 3 minus 1. Because it's all dependent on the term prior. And so that's why I subtract 1 to get back to that previous term. And then I'm going to add my 4, get my difference on there. Nice and consistent all the way through. So this is what ultimately it gets written as, right here. Here's the stuff. So I'm trying to solve for the nth term. So my nth term is my nth term minus 1, all of that plus that common difference of 4. Okay, we're going to play this out. Okay, let's practice it. Something we just need to see it to really see it happening. Okay, so here's my terms. Okay, write the recursive formula, that's what we were just doing, for the arithmetic sequence. So the arithmetic sequence says it's going to be plus 7. So I know already that's going to be plus 7 each time. All right, that's my common difference. So my first term, okay, it is just going to be my 7. Okay, first term is all set. My second term is going to be my first term plus 7. All right, so first term being 70, which we see up here. Okay, first term plus 7, so this is where I get my 77. Okay, let's talk about my second term. Sorry, let's talk about my third term. My third term is my third term minus 1, which is where I'm getting my 2, which is the 77, plus 7 more, so I'm now up to 84. Okay, now I'm going to look at the fourth term. The fourth term is the fourth term minus 1, because it's dependent on the previous one. So my third term, which is 81, plus 7, which gets me to 91. So my ultimate rule here is going to be, I'm looking for the nth term. So it's whatever my nth term is, minus 1, plus that difference that we're finding in each one, which is going to be plus 7 for each one. So it's found by adding 7 to the previous term. And the recursive formula for the arithmetic sequence, and this is the part you got to get. So this is us using it, and then here's the formula, what it looks like. Okay, so I'm trying to find the value of the nth term, and you want to use a to represent this, what I'm looking for. So it's like a function of n is equal to the function of my nth term minus 1 plus my difference. This is the pattern you want to get comfortable to writing. That is my recursive pattern. So the ultimate question was back at the beginning was to find the eighth term. So we need to find the eighth term on all of this one. We knew that it was 98, 105, 112. Okay, so my eighth term is my seventh term plus 7. So 112 plus 7 is 119. Yep. All right, this is going to take some practice. It's kind of like some crazy stuff, but I want you to try it out. So for each one of these patterns, you're going to find the arithmetic sequence. Use the arithmetic sequence to find the ninth term in each one. But you might as well go ahead and create that pattern to get used to it. Press pause and try it out. All right, here's how they all look. Now notice very similar pattern here. You got this guy with the arithmetic sequence. You got this guy with the arithmetic sequence. Recursive pattern is showing this same thing. It's the term I'm looking for, minus 1. So I'm looking for the enter, and then the common difference, okay? And it looks like the ninth term for each one of these 51, 119, 11.3, and 25. And you can see this is the way I write it. Okay, the function of 9 for each one of these. It's going to take some practice. Okay, so now that we've got the recursive formula, we're also going to look at one called an explicit formula. This adds one more element to it. Now it's interesting because you can also write a sequence using the explicit formula. So what this is you can use the recursive formula or the explicit formula. Both of these will get you the same results. It's interesting because both of them use first term. Both of them use the term you're looking for. Both of them have minus 1 in it because it's dependent on the number before it. And both of them have the common difference in it. Look what's different about this guy though. Okay, so this looks the same. Okay, this looks the same. But look what's different here. We're including our first term in there, and it's being added on. So my first term, it's added to the previous number times the difference. Okay, let's play this out a little bit. You just got to see a few of them. Okay, we're going to write the explicit formula for what's going on here. All right, we're making bids on some things. So bid number 1. Okay, so term number n. Bid number 1 was $200. Bid number 2 is $210. Bid number 3 is $220. And bid number 4 is $230. All right, and there's my explicit formula, all my different pieces to it, and I want to create that here. Yeah, my explicit formula. So I can see that the difference between each of these is going to be, looks like plus 10. Okay, my arithmetic sequence. So let's go ahead and put this together. So a function of n. Now I'm going to find, let's see. So a to the n, it's my formula, which is my first term on this one. So we actually know our first term. Our first term is 200. Okay, and I'm going to add it to n minus 1. I'm going to multiply it by the difference, which is 10. So here is my formula that I'm working with. My recursive formula. I've got my first term. I got my recursive pattern. I've got my difference between them. So now I can solve it. I believe it's asking for what the 8th one is. What is the 12th bid? Okay, let's go ahead and work out and find the 12th bid on this one. This is going to be a to the 12th bid. Okay, I'm looking for that. I've got my original 200 plus my 12th bid minus 1, and that's going to be times 10. And if I get all this worked out, I find out that my 12th bid is actually $310 when I simplify this whole thing. All right, press pause. You give it a try. Okay, a couple elements here is, okay, starting value of 100, which is right here. I've got my recursive pattern, which is right here. I have now noticed this is we're subtracting because we're spending it. Okay, the value is going down, so that's something we had to keep an eye on. It's going down, and notice this right here. This is my 175 that's happening as it's changing each time, and that's something you had to calculate. You had to determine that pattern out there. And we worked this out, and we found that B was, how many rides can be taken? It's 57. 15 rides, right there. All right, last thing is the very last one. You're doing great. Keep hanging in there. Write an explicit formula from a recursive formula. Okay, an arithmetic sequence is represented by the recursive formula. So you know you're looking at a recursive formula when you don't see like the starting term here. So that's really part of the difference. So we were missing our starting term, and this right here is our differences being added on. So this guy right here, recursive formula, has our n minus 1, and I'm adding the difference. Okay. So an explicit formula, really the only difference is that I'm looking for, okay, I need my starting value, which I don't see here. So I'm going to look over here, and I see that the first term is 19, so I can put that in there. 19, right? Okay, plus n minus 1. And then what's going to happen is my difference here, my 12, my difference that's happening to each one, I'm going to go ahead and multiply that on there. And it's going to be adding each time unless I look at the story of it, and the story shows that it's changing, it's decreasing in value each time. In that case, I'm going to want to put plus. Whew. All right, I'm going to go stick my head in a bowl of Jell-O and see how long I can hold my breath in a bowl of Jell-O. Yes.